Hi, everybody. Welcome to video number 2 for my UROP R series. So last week, we talked a little bit about just like why we're using R in the first place, why it has benefits over Excel. We opened up R, we looked at our studio, kind of the different panes, the different things going on. And then we started looking at that MT cars data set, that built-in data set. We saw how a data frame is composed. You can think about a data frame as composed of vectors, of variables. And we looked at how we could find the minimum, the maximum, et cetera, of those columns. So today we're really going to ramp things up, and we are going to look at reading data into R. We talked about this a little bit in class. I'm going to go over it again just so we're make sure we cover all our bases. And then most of the time we're going to talk about things we do to data sets. And to motivate this, I have some real data that we're going to be working with, which is basically the roster of state employees in Mississippi. That's the most current data I have. It's from June of this year, June of 22. So we're going to be using some real messy live data rather than some canned car data. So let's go over kind of the first steps here in setting up an R project again. Really briefly, I know we did this in class, but I think it's helpful to go over it again. So let's open up our studio. So what do we want to do? We want to set up a project that, and the key thing that this is going to do is it's going to give R a place from which it can look for our files. If we right now wanted to read a file into R, it would look for that file here in the very, very root folder on my computer. This is not where you should be sharing stuff. You should be creating a lot of folders and subfolders and have a folder specific to the given project that you're working on. So for instance, I have a folder called state bureaucracies. Every single thing that I am doing related to my state bureaucracies project is inside that folder. And even further within that, I have a code folder, I have a data folder, etc. So what we want to do is whenever we open up our studio, we want R to know that we're working in a given project and to kind of start looking for files from that point, relative to that point, rather than relative to this users gearing folder all the way kind of at the back end of our computer. So how are we going to do that? We're going to do that by creating a project up in this upper right-hand corner. And this isn't something you're going to do every time you work with R. This is going to be a kind of like a one-off thing. So we're going to create a new project. Computery thing, directory and folder are synonyms. So this is saying, do we want to create a new folder? Do we want to make it as part of an existing folder? I'm going to do new directory. I'm going to create a new project. I'm going to say, where do I want that project to live? I'm just going to put it in this study folder. I'm going to give it a name, UROP video 2. I'm going to create a project. Our studio is going to refresh. You're going to see that up here now we're in this UROP video 2. What has this gotten us? Now, if we wanted to read a file into R is going to start looking for that file in the UROP video 2 folder, which is super helpful. Super, super, super helpful. Okay, so now let's take a step back, close out of our studio. Now, from now on, whenever you open up our studio, except for times when you are like creating a new project, doing a really small one-off thing, if you're working on one of your R projects, I want you to open up our studio from the project. So what does that mean? That means rather than clicking on this icon here or the equivalent thing, if you're on a PC, I want you to go to your folder system. I want you to go to this project you just created, this directory, this folder, and you'll see that there's this .rproj file. And if you double click on this, you're going to open up RStudio, but you're going to open it up from this place. And so it's going to start looking for files at that place. All right. And you'll see we're in the project because it says UROP video 2 up there. Okay, cool. So let's go back to our UROP video 2 folder. And let's just kind of make this a little bit more realistic. Let's say we're going to have a data folder in here. We're also going to have a code folder. In the folder with the video links, there will also be, there's now an example data folder. And I want you to place, if you're working along with me here, I want you to place that data inside. Oh, I just moved it rather than copying it. Sorry, copy. Paste. Cool. So this data is now inside this data folder within my R project folder. Cool. Okay. So let's go back to our studio. Let's create a new R script. And let's save it. I'm going to say this is UROP2 file. And I'm going to save it inside my code. Cool. So now let's just look at what this looks like. We have this R project file that we're going to use to open up our studio. We have this data folder with our data in it. And we have this code folder with our .r file in it. So if we write a bunch of steps, we write a script to do something with this Mississippi data, we're going to be able to come back to it, keep working on it, rerun it, etc. Cool. Okay, so let's go. So now we are in our studio, we are in our project folder, and we have our R file open. So we also talked about this in class, but really what makes R hum is the projects. Or sorry, projects also super helpful. Packages. Packages are really what makes R amazing. Basically, you can think of packages as collections of functions that other people have written that you can use. And in order to use them, at the top of your script, you're going to write library and then the name of the package. And this is a very popular kind of collection, actually, of packages. Tidyverse isn't itself a package. It's a lot of other packages. But this is just an easier way to load them all. I'm going to do that. Note that if you run that and you get an error that says something along the lines of tidyverse package not found, it means you need to install the tidyverse package on your computer. That's just a one-off thing. Library tidyverse is something you're going to run every time you open up R. But once every time, so if you update R, you're going to have to rerun this. But if you're working in R for the first time, you're going to have to run this code, install.packages, and then the name of the package in quotes. If you run that, it might take a few minutes, but that's going to pull the package from the internet onto your computer, and then you can use the library tidyverse. Cool. Let me just keep that. So I don't need to run that. I have tidyverse already on my computer, but I'll keep it there. Note, this is also a good thing to recognize that you can use the pound sign, the hashtag sign, to comment out code. So this isn't, I can't run this right now. I'm trying to run it, can't run it, and that's because it has this hashtag out front. If I delete this, then this is real R code that I could run. So if you want to write notes to yourself, kind of give some comments to the code you're writing, which you should definitely do. We can talk at a later point about like what good code comments look like, but you can do something like read in data, right? That's not our code. That's just words, but it's going to help make your script a bit more readable to other people or to yourself at some future point. Okay, so let's read in our data. So the file in our data folder is a CSV, comma, separated values. It's a very common type of data. Data can be structured in a lot of different formats. CSV is just one of many. R lets you read in a whole bunch of types of data, whether that's Excel documents, CSVs, TSVs, tab separated values. There's fixed width files that are older usually. There's R specific types of data, which I like, whole bunch of different types of data. So, and you use different functions to read in different types of data, but kind of the general process is going to be the same. So what are we going to do? To read in this file, we're going to do read underscore CSV. That's going to be the function we're going to use. And then you'll see up here, well, actually, let's go down here. I'm going to do read underscore CSV. That's going to pull up the help documents. Super helpful. You'll see that read underscore CSV, the first argument is file. And down here it tells you what file means. File is a path to a file. Cool. So we need to provide the path to our Mississippi data. If I put quotes in there and then press tab, it's going to very helpfully tell me my different options. So in particular, it's in the data folder, and it's that one. Remember that since we've created this R project, R is starting to look for stuff from the UROP video 2 point, relative to that point. So this path is relative to that point. The full path to this file is much more unwieldy, as it would look something like this, like that. That's the full path to that file. So you could also do read underscore CSV that. If you weren't in an R project, but just don't worry about that. Since we're in an R project, everything's relative to this UROP video 2 folder. So we're going to start looking from there. So we're going to go into the data folder, then we're going to find our CSV. So if we run that, it's going to create this data frame here. It's going to read it in. But you'll note that we haven't saved it. We haven't attached a name to this folder, to this data frame. So I'm going to call it MS for Mississippi raw. I'm going to run that. Now you'll see that our data frame is up here. Cool. It's provided us some helpful things here. It's told us that these columns are read in as character variables. These columns, these 3 columns, are read in as DBL. DBL means it's a number. R is thinking about it as a number. Double refers to this like double point precision floating thingamajiggy that you don't need to understand, which is basically just like how a computer thinks about numbers. It's over my head. I won't worry about it. If you see double, that means a number. And then you'll see that this one is read in as a date. Cool. So we have MS raw. So now we actually have real data that we care about rather than this empty cars data set, which is a great place to start. So what I want to talk about today is kind of 4 verbs, 4 functions that you're going to use often when you have a data frame like MS-RAW. Those 4 functions are going to do the following things. They are going to filter rows, select specific rows. They're going to select specific columns in your data frame. They're going to create new columns in your data frame. And they're going to summarize the information in your data frame. So let's go through these one by one. So let's say that we wanted to create a new data frame of all the African Americans in our Mississippi data. Okay? So we want to filter down to only the rows where race equals African American. So the number of rows in this new data frame is going to be less than the number in MS-RAW, right? We're going to do that with the filter function. What does filter do? So let's say I'm going to create a new data frame called MS-RAW African American. What in words do we want to do? We want to filter MS-RAW so that we're only selecting rows where race equals African American. So that's the in English part. How do we translate that to our code? Well, with filter, what we're going to do is the first argument here, this is going to be a common theme. First argument is going to be the data frame to which we're doing the action to. So in this case, that's MS-RAW. We're filtering MS-RAW. Comma, to go to the second argument. What's the second argument? The second argument is how are we filtering MS-RAW? And in particular, we're filtering MS-RAW to only the rows where race equals African American. A couple things here. First thing is you'll note that unlike in the general case when we were doing like some MT cars, MPG, or let's do mean MT cars, MPG. In this case, we had to provide MT cars $, because otherwise MPG doesn't exist on its own. MT cars exists, and within MT cars exists this MPG variable. When we're doing this, though, it's a little different. Within the filter function, we don't need to write this. That is an unnecessary redundancy. Filter knows that it is filtering the MS-RAW data frame. And so it's going to look for the race variable. If race doesn't exist, let's say we do race 2, this isn't going to work. Caused by error, object race 2 not found. But since race is a variable, filter's going to know to look for that and to find it. Cool. Next thing here. If you've done some programming, this might be familiar. If not, this will be something new. 2 equal signs here means a test of equality. a test whether a statement is true. One equal sign is more so assigning a value to an object. One equal sign is actually very similar to this assignment operator. And actually, I'm kind of, part of me doesn't want to say this because you shouldn't do this. It's not good practice. But this is actually the same as this. These will both do the exact same thing. They will both assign the value 10 to x. What the two equal signs are going to do are going to say, is it true that 2 plus 8 equals 10? Yep. Does 2 plus 8 equal 12? Nope, it's false. So when we're filtering, we're going to use two equal signs because we want to know whether a given row is equal to African American. Okay, last thing here. African American is in quotes. African American is a specific value that the race variable can take. We're going to put it in quotes to denote that. If we were filtering by a numeric variable, what was a numeric variable? FTE underscore percent. Let's say we wanted to filter to the full-time employees. I'm kind of running this ad hoc right now. Call names of MS Raw is going to pull up the column names. And I want to do FTE percent. That's how that would look. This code is filtering MS Raw to only the cases where race equals African American. Since race is a character variable, we need to put its value, which could be African American, in quotation marks. FTE percent, not character, it's numeric. So we're not going to quote it. Let's run these. Oop. And that's raw. FTE percent. So you see I screwed up. FTE percent is not actually a percent. If we wanted to be specific here, it's actually a proportion. And so this should be 1. There we go. Okay. So now we have 3 data frames. We have MS Raw. That's everything. That's what we read in. MS Raw AA, that is our universe of Mississippi employees whose race is African American. MS Raw FT, that is the universe of Mississippi employees at this point in time, again, which is June 2022, who are full-time employees. Cool. So that's filter. That's our first verb. Filter rows. Next one. Select columns. Filter for rows, select for columns. Okay, let's look at MS Raw again. Let's say for some reason, so let's just look at this real quick. Month observed, I've filtered this, I got a smaller version of the data so that it would just run faster. I have like 3 years worth of months. So this is just a subset of the data that I have. I have 2019 through 2022. So month observed is the month. And then we have this person ID, which Mississippi has very helpfully added, which tracks somebody's tenure throughout the state public service, public workforce. And then we have all this name information, their race, their sex, their job title, the agency they work for, all these goodies, their current salary, etc. Cool. So let's say that I wanted to select person ID and first name and last name. So I wanted to create a new column, a new data frame that only has 3 columns, same number of rows. Okay. Let's do MS 3 calls. How do we select specific columns? We use the select function. Select. Same thing with filter. We are selecting upon MS raw. So that's going to be the first value in our function. Then what do? Then we tell R which columns we want to select. Person ID, first name, middle, let's do middle name, and last name. So now you'll see, oops, and I ended up with 4 columns. That's funny. We'll take out middle name. MS3 calls has the same number of rows as MS raw, but only 3 variables. If the variables are next to each other, so in this case, let's say we want to select all the variables between person ID and last name. How many is that? 1, 2, 3, 4, 5. MS5 calls. Rather than listing them all, you can do person ID colon last name. That's going to select all the columns between person ID and last name, including person ID and last name. Okay. So let's add these 2 things together. Okay. And let's say we want to select, let's say we want to find all of the first names of Caucasians who work for the state of Mississippi. All right. Let's call it MS. So let's just think about this for a second, kind of in words. What do we want to do? We want to filter to only cases. Remember, we want all of the first names of Caucasians in our data set. So we want to filter down to only look at the rows where race equals Caucasian. And we are only interested in one column. We're only interested in selecting the first name column. All right. So let's first filter MS raw to only the rows where race equals Caucasian. All right. In this case, we're going to overwrite this data frame, which I'll talk about more in a second. But let's use the same name here. And now we want to only select we're selecting from MS Caucasian first names, right? We're not selecting from MS raw because MS raw has everybody. We've already filtered down to only the folks who are Caucasian. So we're going to select the first name column from that already filtered data frame. Which column are we selecting? We're selecting first. Okay. Usually the variable names pop up. I'm not sure why they are not filling in right now. Cool. Right? That's pretty neat. One last thing we probably might be interested in is right now there's probably a lot of duplicates in here. There's probably a lot of Pauls. There's probably a lot of Johns, a lot of Marys. Let's say we only want the distinct, the unique names. This is just another function for you to familiarize yourself with. Distinct is also going to take this as the first argument. And actually, we don't have to pass anything else to it. It's just going to find the distinct rows in our MS Caucasian first names. So let's look at this step by step. So you'll see here, we have almost 9,400 rows when we filter to only the Caucasians, and then we're just selecting that first name variable. If we take out the duplicates with distinct, we're going from 9,374 to 1,729. Now we have all the unique names. Cool. Next up, summarize. Summarize, another verb that's super helpful. Summarize is going to, we're also going to do this very helpful function called group by. So summarize is going to summarize our information for us. It's going to provide a framework for calculating means, for getting counts of stuff, etc. And it's most helpful in conjunction with group by. Group by is, so let's go back to empty cars, or actually let's just stick with this data set. Let's say we just want the mean salary for the state of Mississippi. Empty car, or MS raw, I think current salary, mean. This might return NA. Let's see. It doesn't. There's no NA values. Cool. So this is the mean salary for our Mississippi employees, right? We went over this in the first video, which is cool. That's interesting. But usually we're interested in more interesting stuff. That was kind of, by definition, a silly thing to say. But usually we want to know things like, let's look at the mean salary by race. Let's look at the mean salary by sex. This framework is a little tricky to do that, right? What we want to kind of do in words is thinking about, let's take our data frame, let's take MS raw and group it so that we're only calculating mean. Let's say, let's do the case of sex. Let's say we're grouping our data set by sex. That means we're telling R to only calculate mean for each respective group. So calculate the mean salary for males and the mean salary for females. So summarize and group by are going to be our way to do that. So first thing we're going to do is, well, actually, let's do this without grouping first. So let's say we want to do summarize. What data frame are we summarizing? We're summarizing MS raw. What do we want to know from MS raw? That's going to be the second thing we're going to be passing here. And we want to know the mean of current salary. And again, this is kind of weird. We don't have to do, when we're in summarize, we don't have to do this. Because summarize is going to know that current salary is a variable in MS raw. It's a little bit less specific, but what you gain from that is a lot more legible code that has a lot less redundancies in it. Okay. What is this returned? This is returned the mean current salary is about $45,000. If we wanted to give that a name, we could do that. Right now, the name is this thing, which is a little unwieldy. Let's say we want to say the name of that variable. It is a variable. It's just in a data frame that's one column and one row. Is going to be mean underscore salary. There we go. One thing to note here, we haven't talked about yet. Tibble is an amazing word. A tibble is a fancy data frame. It's has a lot of benefits over data frame. We don't need to go over them now. You're welcome to Google it. But if you see a tibble that's a 1x1, for now, you can just think about that as a data frame that's a 1x1. Okay. So that's cool, right? We've calculated our mean salary. But this, again, this is the same thing as mean MS raw current salary. We want to group this and calculate it by sex. So what are we going to do? Mean salary by. So let's create this data frame that's MS grouped. MS grouped. We're going to use group by, group underscore by. First argument is going to be the data frame, MS raw. Which data frame are we grouping? And then what variable are we grouping by? In this case, we're grouping by the sex variable. All right. That's not actually going to print anything out for us. It is going to create this data frame, MS grouped sex, which is going to look the same to the naked eye as MS raw. But if you look at the structure of it with str, you'll see that it's a grouped data frame. It's a different type of thing. And it's going to be most apparent in the next line of code. So now let's go up here. And rather than summarizing MS raw, let's summarize MS grouped sex. Now we're calculating the mean salary, the mean current salary, but we're doing it on a group data frame, which means that our output is going to be for each of these. Each of the groups, each of the unique observations in our grouping variable, sex. Cool. Okay. Let's copy this. Mean salary by race. What do we want to do now? We want to calculate the mean current salary for each racial group. So now, rather than grouping MS raw by sex, we're going to group it by race. And now we have our mean salaries for each race in our data set. Let's say we wanted to also know, like, you know, how many American Indians are there working for the state of Mississippi? If we can add another variable here in our summarize. So let's summarize MS grouped race, not only by the mean of current salary, but let's also create this N race, which is just going to be equal to this N function that's empty. This is kind of weird. This is kind of weird. This is just going to calculate the number of rows in each group. We don't need to tell it anything. It's just going to know to calculate the number of rows by group. So not that surprisingly when you think about the demographics of Mississippi, but most employees in the state of Mississippi are either African Americans or Caucasians. The vast majority are either African Americans or Caucasians. And on average, Caucasians make $50,000 a year versus African Americans who make 40,000. All right. So what have we done so far? We've learned how to filter rows. We've learned how to select columns. We've learned how to summarize our data. The last key verb I want to talk about is creating new columns. With mutate. All right. So right now, we've just taken this data set in and we've learned things from it. It's a cool data set. There's a lot of cool things you can do with it, but it is oftentimes, all the time, we want to create new things. We want to create new variables that we can look at and analyze, right? And right now we don't have the tools yet to do it. What we're going to do is we're going to use mutate to do so. So let's look at MS-RAW and think of a cool variable to create. All right, so let's just do a simple case at first. Let's say right now we have a race variable. But you could also think about and maybe for some reason we want to create this. It could definitely be the case in an analysis that you'd want to create this. You want to create another variable that, let's just call it white. And it's equal to 1 if somebody is Caucasian. Otherwise, it's equal to 0. All right. So we're creating a new column called white. It's equal to either 1 or 0. 1 if somebody is Caucasian, otherwise 0. Create this new data frame, MS new call. We're going to use mutate. Which data frame are we mutating? Which data frame are we adding a column to? MS raw. Now, we're going to give the name of our new column and say what it's going to be equal to. We're going to call it white. It's going to be equal to. Note here, we're using 1 equal sign because we are creating a new column called white. We are not testing for whether something is true or false. That's going to be happening. Well, actually, hold with me because it's actually going to be happening in just 1 second. So what is white going to be equal to? White's going to be equal to 1 if somebody's Caucasian, otherwise 0. So you could think about this. Let's say that one other way. If race equals Caucasian, then white equals 1. Otherwise, white equals 0. How can we take that from English to R? We're going to do that with if else. There's an if underscore else and an if else with no underscore. 99% of the time, it's not going to matter. If underscore else is a little better. For some reasons we don't need to get into here, so I'm just going to use that. So let's just look at this for a second. If underscore else, first argument is the condition. Second argument is what are we going to return if the condition is true? Third argument, what are we're going to return if the condition is false? Okay. So the first argument is the condition. It needs to evaluate to true or false. Race equals Caucasian. Okay, that's the condition. If that condition is true, if that in that row, that condition is true, what do we want white to equal? We want it to equal 1. If in a given row, race does not equal Caucasian, it equals African American, American Indian, Asian, Hispanic, etc., we want it to return 0. Okay? This is a great way to see these different equal signs in action. Over here, we're creating a new column called white, so we're just using 1 equal sign. Over here, we're using 2 equal signs because we're testing whether race and Caucasian, whether the given observation in the race column is equal to Caucasian. Cool. All right, so let's look at this. We got a lot of objects over here. But you'll see ms underscore raw, 16 variables. ms underscore new call is 17. It has 1 additional variable. All the way over there. Cool. Let me think if I can think of a slightly let's call it good. Let's call it good there. These mutates going to be everywhere. This conditional logic, this if this thing, then return one value. If it's another thing, return that value is also going to be everywhere. And so we'll probably work on this on Tuesday in class. I'll figure out some more complex ones that we can work on together. Okay. So let me check my notes, see if I forgot anything. Nope. Okay. So what have we done today? We have created an R project. We've created some data. We've read it in. And then we've done stuff to it. In particular, we've filtered the rows. We've selected columns. We've summarized information in it. And lastly, we've created a new column. Looking ahead to next week, we are going to talk more about how we could write some of this a bit more concisely. Just as a teaser here, let's look up here at this. You'll see we're doing a lot of assigning stuff. This is the same as MS Caucasian first names. Okay. This, if I wrote this right, this and this are the same thing. This is called a pipe operator. And basically what it does is it says, take this, what's on the left-hand side of the pipe operator, and pipe it into the first argument to what's on the right-hand side of the pipe operator. So in words, this is saying, take MS raw and then filter it so that race is equal to Caucasian. And then select the first name column. And then only take the distinct rows. And then assign all of that to this new object. So take a couple minutes and just look at this. Look at this, and then look at this, and see if you can kind of follow these steps here. I use the pipe all the time. It was really hard for me to write some of this without doing the pipes. This is just, I think, a lot more concise, a lot clearer, fewer opportunities to screw something up, like accidentally putting MS raw here, right? So this is something that we'll talk about more, so that we're going to kind of be more comfortable with that. But this workflow here of taking a data frame, filtering stuff, and then selecting stuff, and then creating a new column, and then summarizing it is like central to what we're going to be doing. So we'll talk about that more. And then we're also going to talk about plotting, which is really, I think, the fun stuff, which is like, let's create some different plots, some different ways to visualize some of this Mississippi game. So stay tuned. That'll be on the docket for next week. All right. Thanks, folks. Bye-bye.